Hey Brandon, this is Mr. Caslin. I want to go over a problem that we talked about on Thursday just to show you the best way to simplify. We were looking at a cube root problem. You have a cube root of the numerator, cube root of the denominator. I think we had decided that it was easier to combine this into one fraction first. You can make this a cube root of just the single fraction instead of the cube root of the numerator and denominator. Okay, and once you've got it in this form, you can simplify the fraction. You know that x cubed divided by x is x squared. We have y squared divided by y to the fourth, which is y to the negative 2, which is why y squared would flip down into the denominator, and then you've got a z to the 7th that doesn't simplify at all. And we said it just in those two quick steps, you've got your answer. Now, what's interesting though is we were looking at this problem, and we said, what if you simplify the numerator first? You have an x to the third, you took a perfect square of x squared out of there, so you'd have x, I'm sorry, it's a perfect cube, so x cubed is a perfect cube, which just becomes x. 3 goes into 7 twice, so z to the 7th comes out as z squared with a z left over. And then you've got y squared that just stays inside the radical. You've got a perfect cube down here. 3 goes into 4 one time, so you have y to the 1 that gets to come out, and a y that stays in. Now, I don't know if you remember this, but we looked at this and I said, how do you know that this is equivalent to this here? How do you know that that doesn't look equivalent to this? We did two different methods. How do we know that those are really the same? Okay, the best way to compare them is you have to probably turn them into rational exponents. Remember, rational exponents are exponents with fractions in them. So for example, if we turn this into rational exponents, in the numerator we would have x to the 2/3. Excuse me, I'm writing with a mouse, which is hard for me to do. And then z to the 7/3. Remember, your index always becomes the denominator of the fraction. Now this is going to be y to the 2/3. Okay, so now if we convert these to rational exponents, is it going to match this? Get a little more work to do that. Let's turn this back to red here. You've got x, you've got z squared. This is going to be y to the 2/3. This is going to be z to the 1/3, all in the numerator. Okay, denominator becomes just y. You've got x to the 1/3, and you've got y to the 1/3. Okay, this is a z squared again. Sorry about the writing on that. Now, let's simplify all of these into their fractional exponents. You've got an, let's see if we can do these one at a time. You've got an x and an x to the 1/3. Remember to combine these fractional exponents, you're going to subtract the exponents. So x to the first minus x to the 1/3 gives you x to the 2/3. Right, so we took care of those. Okay, so our z's, we've got z squared and z to the 3rd. Those are both in the numerators where we're going to add the exponents. So think of that as z to the 6/3 plus z to the 1/3 is z to the 7/3. Okay, that took care of our z's. And now we have our y's. In our numerator, we're going to have y to the 2/3. I'm just going to make a note over here that in the numerator we have y to the 2/3. In our denominator we have y to the 1st. We're going to add the exponents y to the 1/3. So think of that as y to the 3/3 plus y to the 1/3. It's y to the 4/3. Okay, combine this fraction. You're going to subtract the exponents. You would get a y to the negative 2/3, which flips it down into the denominator, y to the 2/3. Anyway, don't mean to confuse you. You don't have to go through all this work. If you just combine, make this one cubed root into one fraction, and then use your rules for dividing exponents, you can get to the answer real quickly. I just wanted to make sure we're clear on we worked it another way and got this answer, and I didn't have a quick explanation for you on why these two are the same. You can't really see that these two are the same unless you put them into rational exponents. In other words, turn them into fractional exponents. Anyway, work your cube root simplifications like here on the left and you'll be fine. We'll see you next time. Thanks.